All right, I did a bunch of problems off screen. So I'm just gonna pick up. I mean, from where I left off. All right. Um. Okay. I mean, I just read the title of this and I scrolled down a bit. Max product subarray. Um, yeah. I think I would need to use a long because of the 32-bit integer here. Um, and then okay, there can be negative numbers. All right. So okay. So it has to have an even number of negatives. I don't know if I should like focus on the negatives a lot, like treat them as like a separate thing on its own, or if I should just pretend like I don't need to focus on the negatives, just like do products normally. Um, okay. Okay. So kind of what I'm thinking of initially is like I'm gonna create like an array where each index corresponds to the each index would correspond to the greatest product that starts at index I. Oh wait, that kind of sounds like something DP. Hold on. I don't know. I don't think you need DP. I'm thinking it's like a two-pointer sort of thing here. Um, but I think yeah. I don't know. Um, like so. Okay, you know what? Let me just take this example. Let me just put this in text here so it's like easier to read here. Oh my god, just expand. All right. Okay. So here, like, I would write the maximum product I can get that where if I were to start here. So that would be like that would be 6 in this case, right? And I kind of ignore it. Like I like as I move down the line, I will ignore a particular number if it's of the same sign because that doesn't really change anything. Um, and if it is a switched sign, let's say it's -3 or something, right? Or I guess I'll come up with another example later. But like, if it's the same sign, I ignore it. If it's not, I'll just do the entire computation again. Or wait, actually, what if I store the maximum and the minimum? Um, if I store the maximum and the minimum, and the next one is the flipped sign, all I have to do is kind of wait. Actually, no. Wait, I'd have to wait for like past the flipped sign. So like, I don't know if that makes sense. Like, okay, I'd need a better example for this, so I'm just gonna. Okay, so the example I would be thinking of would be, let's take two. I like the parentheses actually, but let's take 2, 3. Let's take -3 here. 1, -4, 5, -7, and let's take an 8. I don't know. Let's see if this illustrates what I'm trying to say here. Oh, I think I forgot to wait. Yeah, okay, whatever. Forgot to start the timer. Anyways, so like, so starting from 2 would be 2, 3. This would also work. So it would be 2 all the way up to here. So that would be, what would that be? 6, 18, 90, 360, right? So at 2, I would say, okay, 360 is my biggest product. Then I move on here, and 3 is the same sign, so I don't really care because I'm just going to be missing out on this 2. Then when I go to -3, I'm only going to be missing out on 3. Okay. Okay, and then here when I move on to 1, that's when things are going to change because my previous one is -3, right? So then I would say, okay, 1, -4, 5, -7, 8. That is my biggest product. So 28 times 8 is 192? 192? No. 28 times 8, 160. No, 224, right? Yeah, 224. So this part would say, okay, 224 is my biggest. So, okay, so it would be that 360. Then even this guy would say 360, or no, yeah, this guy would say 360. So essentially, if the previous one doesn't change, just like take on whatever was previous. And then this one would say 244. 244, okay. And then when I go here, it still doesn't change. Okay, so it only seems to change when the previous element is a negative number. That's only when the product seems to like kind of give a shit. Now let's test this theory. Like, let's say we have a 0. I think this should work with a 0 as well. I don't think this should change much. So like, again, same example except 2, 0, or sorry, I remember seeing this example up there. -2, 0, -1. Right? So here again, starting at 2, I would say, okay, 0 is my, 0 is just my product, right? And then, so if I encounter a 0 though, I just say, okay, just make it whatever the previous one was, right? And then I get to -1, and then the previous one is a 0. So if the previous one's a 0 or negative, that's when I start afresh. And I look forward and I'm like, hey, okay, it's just -1. Yeah, okay. So if it's 0 or, okay, that makes sense. Okay. So how am I first going to even compute this product where I'm like, hey, look forward? I think I'm just going to do a O of n loop in there to check. So O of n loop to compute product. And then like there's just going to be a, like anytime I get a new one, like a new member, I just do one check to check if, so that's an O of 1 check to check if the previous one's negative. And then if it is, then I do a computation again. So I do another O of n. Okay, so worst case, let's say it's like alternating or something. Even then, it wouldn't be O of n squared. It would be O of n squared over 2-ish. But let's say O of n squared. Or I guess if everything is negative, then yeah, I think it would be an O of n squared solution. But I think that's fine because okay, yeah, this is just, yeah, okay. If this is just like 2 times 10 to the 4, I think that's fine because that's 4 10 to the 8. And I think that's fine. So I'm just going to do long prod 0. And let's say, please tell me this is, okay, so there's at least one element here. I can actually just do long prod equals long of num0, all right? So we just initiate it to the very first person. Because what if it's just a negative number? Okay, I think that is the right way to do it. And then what I would do is, so actually, so I'm just gonna like vector long. I'm just gonna label this DP, but it's really not. It's just not. Because there's no DP that I'm doing here, because I don't think. Oh wait, I guess another idea I had was like store the minimum one as well, and then anytime it's a switch, I keep the minimum as well, if that makes sense. So okay, you know what? Actually, let's just try that out. Actually, how long have? Okay, I'm spending way too long just explaining stuff, and I keep forgetting this is for myself. I'm not explaining to anyone, but I guess it's also to improve my interviewing skills, I guess. So it's whatever. Yeah, maybe the minimum one is too much of a hassle, because like the minimum here would be like if I just multiply everything, right? So that would be, what is that? 6, negative 18, 72, 360, 360 times 56. Okay, well, this is just going to be kind of painful to watch, but like, yeah, okay, 15, 2, oh, I did not know that. Interesting. Is that even right? Minus 12, I don't know why I gotta like always double check if something's right. Is that even right? What's 201 minus 12? That is 189, right? Yeah, okay, that's divisible by 7. This looks like it's divisible by, yeah, it is divisible by 8, 4, and 9. Yeah, and 4 again, probably because it's going to be 004. Okay, or 04, whatever. All right, so yeah, anyways, so it's going to be negative 216. But if I divide it by, so once I get to this point though, this 1, I should keep track of like a product of everything before it. I guess I could just do that with the prefix sum, but that would take some space though, because I would have to divide by negative 18, and that does seem like 244. Okay, I could do that, but that would all. I mean, honestly, I think I should do that because that avoids like a lot of like redundant stuff. But let's say once I get here, then what would the minimum here be? The minimum here would be 1, negative 4, 5. I guess that would be kind of hard to keep track of. Yeah, that would be hard. Okay, you know what? Let me just stick to the O of n squared solution, and hopefully that's just all they care about. So anyways, vector, that's a sidetrack. But I think it's worth exploring just in case I could have saved a whole factor of n in the thing. Okay, but so for the first like thing, okay, so I gotta like compute like the most or like the biggest product for the first element. So so let me just do this. So for auto x in nums, oh wait, or I'm just gonna do like a long p for the prod. P is equal to 1. Then I just do p multiply itself by x, and then prod is equal to max of prod and wait, I gotta make this a long. So max of prod and p. And then what I'm gonna do is just say dp of 0, which corresponds to the first element, is prod. Okay, and then here's where our algorithm begins. So for each element that passes, for, so okay, I'm just gonna do this. If nums.size equals 1, just return prod here. Otherwise, now int I equals 1, I is less than num.size plus plus I. Okay, and then here what I'm going to do is if it's the same, so I'm just going to complete the easy version. So if nums I minus 1 is negative, right? Okay, I don't know if this is a right exact way. I'm just thinking about it. So would there, okay, you know what? I don't know. I don't think it's, okay, maybe it's not flawed. Okay. Okay, nums I minus 1 is, if it's greater than 0, yeah, okay. If it's greater than 0, what I do is I just say, hey, dpi is just going to be dpi minus 1. Else, so if it's less than or equal to 0, then I would do, so then I would create like a long temporary equals, and then I would do dpi, and then I would do for in j equals I plus 1. Actually, let me just do it this way so I avoid any like out of bounds stuff. So for in j equals I, j is less than nums.size plus plus j, I do temp times equals long of nums j. Oh no, not plus equals. So times equals, and then I also do and then, okay, so here's what I'm going to do. So I'm going to just say, so here I'm just going to say dpi is equal to the long version of nums I. And then I'm just going to say, hey, you know what, dpi, and this is what I might do up here instead of like inserting the prod and all that. Instead of all that stuff, actually. Yeah, I don't know. Okay, so maybe I should, I think I'll rewrite that later. But dpi equals, so this is what I was thinking. Dpi is max of dpi and just temp, straight up. And that should theoretically put in the, so by the end of this, dpi should contain, so the goal of this thing is dpi contains the max prod starting at I. And then here's what I'm going to do is I'm just going to do sort dp.begin, dp.end, and then what I'm going to do is return dp of nums.size minus 1. I don't know if any of this is going to run, probably not. Oh, no way. Oh my god. Nah, there's no way. Holy shit. Okay, that is, okay, this is clearly not optimal, so I'm assuming there's an O event solution as well. Maybe what I mentioned was the thing here. So let's just take a look at it. I'm assuming DP. Yep. Okay. Okay. So I guess I was on the using. Okay, one in the forward and backward. Huh. Okay, that seems interesting, but. Okay, let me just look at this thing and hopefully I. Oh yeah, so you do keep track of the min. Okay. Is this like interesting? Okay. Yeah, okay. So I did have the intuition of doing like a sort of DP approach. I mean, as you could see, wow, that's actually crazy. But damn, okay, maybe I should have thought about it more, but like I also like have this issue of spending way too much time thinking, and I kind of just want a solution out. Uh, so yeah, okay. Okay, it's at least good that it's good that I thought of it, so that's fine. Yeah, okay. Um, so okay, so let me just think about this real quick. So let's say I keep track of the min so far, right? Negative 2016 up like up to this point. And as soon as I get here, I'm like, okay, I switch signs. That means I need to take a look at negative min so far and then the product of everything before me. And I can just do that using like a thing or whatever. All right, so boom. So that becomes this. And then oh wait, and then I think I stopped here. Okay, so let me just walk through my. Okay, so I know it's 2016. Let me get rid of all this. Okay, that's a very shitty eraser. Smart erasing. Okay, that's much better. Okay, okay. So it is. So it's 360 so far here, and then min is also negative 2016 here, and it's also negative 2016 here because the min so far is just whatever. You just keep it from whatever it is. And then once I get to 1, I take whatever the minimum is so far, divided by that, and I get 244. So that's my max, but that's not my max so far. Interesting. Okay. Now, if this was like interesting. Okay. Um, and then my max so far becomes this, or no, it doesn't really because that's just 360. But my min so far is still negative 2016, I think. Unless so here, like my min could be like diabolical if like there was like a huge number here. If this is 500 or something, min so far, I guess would have been way worse. But so would my max so far. But yeah. Okay, that's interesting. And then I'm assuming okay, so okay, so you just keep the min so far. Okay, so int temporary max. Okay, yeah, I guess. Um, I am kind of losing. So I guess I gotta fix this too. Maybe this will help me get better, but I'm losing like the brain, like the will to like stay on the same problem. But I guess I will still persist. Okay, let me. Okay, and this was very chopped the way I did this stuff here. Okay, I could also like star this problem and move on, but like, okay, no, I am gonna complete this right here, right now. Okay, so what I'm gonna be doing, I'm not gonna just be copy pasting off here, but I do need some inspiration to kind of speed this up. So, okay, I keep track of the int min and max so far. Okay, that's definitely the method though. And instead of this, what I was thinking was like, instead of prod, I just do directly num0 equals max. Oh, sorry, dp0 equals max of dp0 and whatever p was. That way I don't need this anymore. And I just do dp0 equals like long of nums0. And I don't need this anymore either. And I think this should still work. Okay, wait, hold up. If num size equals, yeah, just return num0. I think this should still work. Okay. Yeah, okay. Definitely better, but like actually no, it's still not better. But yeah, hold up.